video to go over lesson 3.2, which is the product and quotient rules. So these rules you want to use when you're trying to take the derivative of a function that has two terms that are being multiplied together or that are being divided. Before we do the quotient and product rules, though, I want to talk about another function that we haven't seen yet, but we're going to see a lot today. So this is just an aside. We mentioned this back in chapter 1, this number e, which is to do with the natural logarithm, ln. So e to the power of x is a common function that pops up a lot in calculus. It has a really cool property. So this is an exponential function. So e, remember, is just that number 2.718, and so on. So e to the power of x looks like an exponential function. Just going to bring up Desmos here. So here's e to the power of x. Now watch what happens when I graph its derivative. So if you want to graph a derivative, you can just type in f prime of x. If you've defined your first function as f of x. And notice the blue line. Okay, it looks like an exponential function as well. It's actually lying right on top of the red line. So I'm going to just make it a dotted function so you can see it. It's lying right on top of the red line. They're actually identical functions. So this is the only function this happens for. The derivative of e to the x is e to the x. So the slope of any point on the curve e to the x is the slope of the tangent line is the exact same as the function value at that point. So this is the only function that works like this. So f prime, so it's really cool, e to the x. Okay, so that's going to pop up in a couple of examples, and it'll pop up in your assignments too. Okay, so let's try the product rule. I'm going to use a lot of highlighting today so we can see the colors. So the rule is as follows. So let's say you have two terms being multiplied and you know how to take the derivative of both of those terms separately. Then here's what you do. So you take the derivative of the first term. So d by dx, remember, means derivative. And then you leave the second term. And then you add the first term times the derivative of the second term. So I'm using f and g of x to label the two terms, but we won't be doing that down below. We're just going to be using the colors. So you take the derivative of the first term times the second term. Then you add the first term times the derivative of the second term. So let's try that down here. So here's a case where our function is two terms being multiplied together. So whenever you have a multiplication, that's not just with a constant, that's when two actual terms that involve x or whatever variable you have, then you want to use the product rule. So here we have a product, we need to use the product rule. So the answer is going to have the following structure. We take the derivative of the first term times the second term, and we add it to the first term times the derivative of the second term. Okay, so let's see how that looks. So we take the derivative of the first term, so we're going to use the power rule, so bring the 2 down, reduce the power by 1, and then for 3x, the derivative would just be 3. We leave the e to the x alone, and then for the second part, we leave the x squared minus 3x alone, and we take the derivative of e to the x. Now, the derivative of e to the x we just learned is also e to the x. And there you go, you're finished. That's the product rule, so that's the derivative. You don't need to simplify any further. So on the test, if I'm just testing you on the product rule, I just want to know that you can apply the rule. So I'll ask you to stop there and not simplify. However, in the textbook, some of the solutions, so the answer key is going to have it be simplified. So I'll simplify here, but you don't need to on a quiz or a test. You don't need to go farther than this. But we can simplify by collecting like terms and pulling out an e to the x. So there's an e to the x in both of these terms, so we can pull it out. And we can write the yellows together. So 2x minus 3 plus x squared minus 3x. And then we can combine these two as like terms. So the e to the x And I'll write the x squared term first, and then I have minus x minus 3. Okay, so that's the final answer that would be written in the textbook, but all I care about is that you can get to this step here, okay? Let's do another example in addition to that one for the product rule before we move on to the quotient rule. Okay, so I'll call this example 1b. Let's say our function is x to the power of 5 minus 4x squared times root x plus 4. Okay, so if you like, you could pause the video here and try this yourself and then come back and see if you got the right answer, or you can do it along with me. Okay, so I'm going to use the same colors for my highlighting. Here's the first term. There's a product, so we need to use the product rule. So my answer is going to have this structure. First derivative of first term times the second term plus first term times the derivative of the second term. So every time you have a product, you need to use the product rule. Okay, so in this case, the derivative of x to the power of 5 is 5x to the power of 4, and 4x squared, so the 2 would come down to be 8x. We leave the second term alone for the first part. And here we're going to leave the first part alone, so it'll be x to the power of 5 minus 4x squared. And remember, for square root of x, it's x to the power of a half. So we're going to use power rule. The half would come down, and you reduce the power by 1, so it'd be negative half. And the derivative of 4 is, it's a constant, so it would be just 0, so you can just leave it out. And that's your product rule. So that would be the answer. I wouldn't require you to simplify any further than that. Okay, so that's the product rule. You use that whenever you have a product of two terms in your function and you want to take derivative. Next, we're going to use the quotient rule. So this rule you would want to use if you have two terms that are being divided by each other. So if you have kind of a rational function and you want to take the derivative. So I'm going to use the same coloring sort of scheme. The rule is actually quite similar. It has a similar structure, except there's one thing added to it. So you take the derivative of the upper term times by the lower term minus the upper term times the derivative of the lower term, all over the lower term squared. Okay, so let's try and use that rule with this function down here. So we have 4x, that's our upper term, and it's being divided by x squared plus 1. So whenever you have a quotient or two terms being divided, you want to use the quotient rule. So here's what the structure of our answer is going to look like. It's going to be a fraction. On the bottom, we're going to have the lower term squared. And on the top, it's going to look kind of like the product rule does. You'll have the derivative of the first term times the second term minus the first term times the second term. So it looks just like the product rule on the top, except there's a minus instead of a plus. Okay, so we start with the derivative of 4x, which is just 4. We leave the bottom term alone. And then we have 4x times, and the derivative of x squared plus 1 is 2x. And then in the denominator, we have x squared plus 1. So it's not the derivative or anything, it's just literally that written down, but squared. And that's it. So on the test or quiz, you can just leave your answer like this. I don't want you to simplify any further. I just want to know that you can apply the rule in the right time. But in the textbook, sometimes they're going to simplify further. So we'll just do that here. So this we would multiply in. So you get 4x squared plus 4. And here you'd have minus 8x squared all over x squared plus 1 squared. And you would get, so you can combine those x squared terms. So minus 4x squared plus 4 all over x squared plus 1 squared. And you can pull out a negative 4. So you have x squared minus 1 all over x squared plus 1 squared. Okay, so you could write it like this. That's fine. Or you could write it like this, which you'll do on the test. Okay, so I don't want you to simplify any further on the test. If all the question was asking was to find the derivative. Okay, so that's the end of the lesson. However, I want to do one more example where we combine both the product and quotient rules, because sometimes you have to apply more than one rule to do the derivative. So I'm going to call this example 3. And in this example, e to the x is going to be involved again. So in the numerator, I'm going to have x e to the x, and in the denominator, I'm going to have x squared plus 1 again. Okay, so if you want, you could pause the video here and try and do the derivative. Okay, so this is a quotient because in the numerator, we have x e to the x, and then in the denominator, we'll have x squared plus 1. So my answer, my derivative, is going to have that quotient rule structure to it. So I'm going to have the denominator squared in the bottom. On the top, I'm going to have the derivative of the top times the bottom minus the top times the derivative, I'll make that a bit bigger, times the derivative of the bottom. Okay, so however, when I'm doing the derivative of x e to the x, that is a product between x and e to the x. So this is a product, so I need to use the product rule when I'm doing the derivative of the yellow part. Okay, so sometimes you need to do a rule inside another rule. So overall, we're doing quotient rule here, but when I'm doing the derivative of that upper piece, I need to use the product rule. So the product rule, remember, so I do the derivative of the first term, which is 1, leave the second term alone, plus leave the first term alone and do the derivative of the second term, which is e to the x. Okay, so that's the product rule for the yellow piece. I've done the derivative now. I just leave the bottom term as it is. And now I'm going to leave the top term and do the derivative of the bottom term. The bottom term is not a product, so I just do the derivative like normal. It's going to be 2x. And then I have all over x squared minus, or plus 1, all squared. Okay, so you can leave your answer again just like this. I don't want you to simplify anymore. But that's a case where you have to do one rule inside another rule. So that would be the solution there. Okay, so that's it for product and quotient rule. End the video.